Good morning, children. Today we have to learn the new topic, complex numbers and quadratic equations. So what's a complex number? What is the solution of this quadratic equations? Last year you have studied how to solve quadratic equation using quadratic formula and all. So it's a quadratic equation. So what is the root of this quadratic equation? X square is equal to minus 1 or x is equal to plus or minus root of minus 1. So what we write? There is no real root. If negative numbers comes inside the square root, then we can say that are imaginary numbers. No real root for this quadratic equation, only imaginary roots. So what do you mean by an imaginary number? An imaginary number or the same as complex number means a number, it's a number. It is denoted as Z. So a number is of the form A plus IB. That is known as a complex number, where A and B are real numbers. A and B belongs to the set of real numbers. A and B are real numbers, and this I is root of minus 1. That is I. So such type of numbers, that is known as complex numbers. And this A is this A and B are real numbers. This A is known as real part of the complex number and B is known as imaginary part. So we can write A is equal to, it is the real part. We write just RE of Z, and B is the imaginary part. We write only I and M, IM of Z. So for example, 2 plus I root 3. It's a complex number. This is in this form A plus IB. So it's a complex number. Or minus 5 by 3 plus I4. It's a complex number. So a complex number means a number of the form A plus IB. It is denoted by the letters Z. Then where here A and B are real numbers and I means root of minus 1. A is known as real part of Z and B is known as imaginary part of Z. The second part is the imaginary, but the first part is real part. So these are some examples of this complex numbers. Then two complex numbers are equal means. Suppose let Z1 is A plus IB, it's a complex number, and another complex number Z2 is equal to C plus ID. Then Z1 is equal to Z2. That means A plus IB is equal to C plus ID. This implies two complex numbers are equal means real part are equal and imaginary part are equal. That is the meaning. So we can write as A and C equal, comma, B and D equal. Okay. So for example, if x plus iy is equal to 2 plus I5, then can you say what is the value of x? This is a complex number, this is also a complex number. Two complex numbers are equal means real part, which is the real part, x is the real part, that is equal to real part 2. And the imaginary part y is equal to imaginary part. So in this way we can find. Okay. Now the next is algebra of complex numbers. That means we have to learn how to add, subtract, multiply and how to divide two complex numbers. So the first operation is addition. So let Z1 is equal to A plus IB and Z2 another complex number C plus ID. And how we add Z1 plus Z2, A plus IB plus C plus ID. How we add? Add real part, then add imaginary part. So A is add to C. A and C we can add, put a bracket, plus I into B plus D. Okay. So, this is the way we can add two complex numbers. So, for example, if 2 plus I 3 plus minus 5 plus I 1 by 2. How to add? So, you can add 2 and minus 5. Okay. Plus I 3 plus 1 by 2. So, it is minus 3 plus I 7 by 2. This is the way of addition. Now, properties are there. We have to learn properties. Properties of addition. The first property, closure property. What do you mean by closure property? Closure property means when we add two complex numbers, the result is also a complex number. That is known as closure property. The second one is commutative property. So, commutative property means A plus B is equal to B plus C. That is Z1 plus Z2 is same as Z2 plus Z1. Then third one, associative property, associative law. So, we have to take three complex numbers Z1, Z2 and Z3. Z1 plus Z2 plus Z3 is equal to Z1 plus Z2 plus Z3. This is associative. Now, fourth one, existence of additive identity. Existence of additive identity. So, for normal addition 2 plus 0 is equal to 2. 0 is known as additive identity. So, here also we can define a complex number of the form 0 plus I0. Actually, it is 0 itself. So, we can say a complex number 0 plus I0 such that Z plus 0 is equal to 0 plus Z is equal to 0. So, 0 is the additive identity. 0 we can write as complex number as like this. Okay, both real part and imaginary part are 0. So, 0 is the additive identity. So, fourth one is existence of additive identity. 0 plus a complex number gives that complex number itself. Then fifth one, additive inverse. If a plus ib is the complex number, then we can find a complex number minus a minus ib such that a plus ib plus minus a plus minus ib. What is the sum of this? A and a cancel, ib and minus ib cancel. So, we get 0 or 0 plus I0. 2 plus minus 2 equal to 0. So, minus 2 is known as additive inverse of 2. The same way, for every complex number, there exists a complex number minus of that. So, if z is a complex number, there exists another complex number minus z such that z plus minus z equal to 0. Okay? So, that is existence of additive inverse. So, these are the properties, okay, for addition. First is closure property, that is when we add two complex numbers, the answer is also a complex number, that is closure property. Then Z1 plus Z2 is same as Z2 plus Z1, commutative property. Associative, Z1 plus Z2 plus Z3 is equal to Z1 plus Z2 plus Z3. Then there exists additive identity, that is 0. Then additive inverse, for every complex number z we can find a complex number minus z such that z plus minus z is equal to 0. Now, the next is difference of two complex numbers. So, let z1 is equal to a plus ib and z2 is equal to c plus id. What is the difference between these two complex numbers? Z1 minus Z2. So, a plus ib minus c plus id. Again, real part you have to do, then imaginary part. So, a minus c, that is real part, put in a bracket, then I into b minus d. This is the way you can do the difference. Okay. Now next is multiplication. Multiplication of two complex numbers. So let z is equal to a plus ib z1 and z2 is equal to c plus id. How we multiply z1 into z2? Okay. So we write a plus ib into c plus id. A plus ib into c plus id. Now open the bracket. Multiply a with c, then a with id, like that. So you will get 4 terms. So first is a into c, that is ac, plus a into id. So iad, that is the imaginary part. Now second term is ib. So ibc plus I into I, that I can write I square b into d. Okay. What is the value of I? I is root of minus 1. So what is I square? It is minus 1. So we can write AC plus IAD plus IBC minus BD. So which are the real part here? AC is the real number, BD is also real number, that is minus. So AC minus BD is the real part, plus I into AD plus BC. So this is the product of two complex numbers Z1 and Z2. So just you have to multiply, that's enough. So wherever I is there, I into that. So you will get real part and imaginary part. Okay. Now what about the properties? Properties. When we multiply two complex numbers, Z1 and Z2 are two complex numbers. When we multiply, what about the result? That is also a complex number. So product of two complex number gives a complex number, that is the first property, closure property. Now the second one, Z1 into Z2 is same as Z2 into Z1. That is always true. That is known as commutative property. Now associative property. What is the associative property? Z1 into Z2 Z3 is equal to Z1 Z2 into Z3. Okay. Now existence of multiplicative identity. 2 into 1 is equal to 2. So which is the multiplicative identity? 2. 1 into any number gives that number. So here also 1 is the multiplicative identity, but 1 how we write as a complex number. 1 means it's a real number. So we can write 1 plus I 0. That is imaginary part is 0. So any complex number a plus ib into this 1 plus I 0 gives that number itself. Isn't it? When we multiply a into 1 is a, the second part 0. Then ib into 1 is ib into second part is 0. So we get the same a plus ib. So this is known as multiplicative identity, or simply 1 is the multiplicative identity for complex multiplication of complex numbers. Then what is the multiplicative inverse? What is the multiplicative inverse of 2? 2 into 1 by 2 gives 1. So 1 by 2 is the multiplicative inverse of 2. The same way, if a plus ib is the complex number, then a plus ib into its inverse 1 by a plus ib gives 1. 1 or 1 plus I. So this is known as multiplicative inverse. Multiplicative inverse. Okay. And this denominator cannot be 0, that is a and b cannot be 0. If it is 0, it is not possible to find. Okay. Now the last property is distributive. That is Z1 into Z2 plus Z3. That's equal to Z1 Z2 plus Z1 Z3. Okay, or we can write Z1 Z2 into Z3 is equal to Z1 Z3 plus Z2 Z3. Okay, so this much properties for multiplication of complex numbers. Now the next is division. How to divide two complex numbers. So let Z1 is equal to A plus IB and Z2 is equal to C plus ID. Two complex numbers. And how we divide? How to find the quotient? Z1 by Z2. A plus IB by C plus ID. Always here the denominator is complex number. So you have to rationalize. For multiplicative inverse also, if 2 plus I3 is a complex number, what is a multiplicative inverse? We can write 1 by 2 plus I3. But this is not the final answer. You have to rationalize the denominator. So rationalize means you have to multiply. Multiply by what? Multiply by its conjugate. So what do you mean by conjugate? In 9th standard you studied now 2 plus root 3. 2 plus root 3 in the denominator, you multiply by 2 minus root 3, numerator and denominator, for rationalizing. The same way. So C plus ID, look, if Z is C plus ID, it's a complex number. Then its conjugate means this sign you have to change, that is C minus ID. So multiply the numerator and denominator by C minus ID, then only we can rationalize the denominator. So A plus IB into C minus ID. Here also C plus ID into C minus ID. Now multiply. A into C AC minus IAD plus IBC minus I into I square BD by this of the form A plus B into A minus B. A plus B into A minus B is A square minus B square. So what is A square? Real part square minus B square, imaginary part square. That's enough. Otherwise you can multiply. You will get 4 terms, 2 cancelled, then again you will get like this. Okay. Now again simplification. AC minus IAD plus IBC. I is equal to root of minus 1. So I square is minus 1. Minus I square becomes 1. So plus BD by C square minus I square D square. Again I square minus 1. Minus 1 of minus becomes plus. So we can write what are the real part in the numerator? AC and BD. Okay. So AC plus BD plus I into BC minus AD. Okay. Then by C square plus D square. Or we can split it and write. Always you have to split it and write. What is the real part? AC plus BD by C square plus D square plus I into BC minus AD by C square plus D square. So this is the way we can find the quotient, or we can divide two complex numbers. No need to by heart this is the method. You have to always rationalize the denominator for finding multiplicative inverse, and for the division of two complex numbers you have to do that. Okay.